I'm going to start talking about vectors. And the first thing that we need to know is, what is a vector? So a vector is a quantity that has a magnitude, so a size. I could say that this is 3 units long. That would be my magnitude. But it also has a direction. So a direction could include that this is at a 45-degree angle. Okay, now these quantities are described in different ways. It kind of depends, and you'll learn more about that as we go. Now, the difference between a vector and a scalar is we just have a magnitude for a scalar, not a direction. So let's first talk about how some of these things are identified. So it's called a position vector, and depending on the book, it could be represented as 2 letters with an arrow over top. It could be a bold, and often we simplify it just to be 1 letter, the expression of the vector. So you'll see this as we go through. Now, if we have a vector, we can always create its negative vector where it has the same magnitude, so it's the same size, and it is the opposite direction. So here's an example of AB. The way that it's identified as a vector is with the arrow over top. Now notice that BA is in the opposite direction. So we could also say that AB is equivalent to negative AB, which is equivalent to BA. So notice that our A is where we start. Our B is where the tip of the arrow is. So we call this a tail, and we call this a tip. So let's look at this first example. We have a parallelogram, P, Q, R, and S. And we're asked to just identify the sides as vectors with expressions using A and B. So we're told that our tail is at P, our tip is at Q, and that has the expression A. We're told also that we have QR, tail, and tip. Find a vector expression for QP. So QP is just the opposite direction, but it has the same magnitude. So I can call that, now we have to use the expression, so I can call that negative A. For B, we have RQ. Same magnitude, opposite direction. So if QR is B, then we have negative B. For C, we have SR. Now SR is actually also A. It has the same magnitude and it's at the same angle, so direction. It's just moved parallel, but it's still identified as A. And D, which is SP, has the same magnitude as QR, but again, it's the opposite direction, so we would call that negative B. In our next example, we're asked to graph. So the first thing I want to show you is that my A vector has a horizontal component of 3 units, and it has a vertical component of 4 units. So I need to use that exact same direction when I'm creating my A vector. So I'm just going to start anywhere. I'm going to start with my tail here. I'm going to do 3 units to the right, 1, 2, 3, 4 units up. And then I have my arrow. So here's my A. And when I'm going to add B to it, I'm going to take B, and I can see that this has 1, 2, 3, 4 units that's horizontal and -2 that's vertical. So from my tip, I'm going to do 4 units, 1, 2, 3, 4, and then 1, 2. And here's B. Now my resultant vector is my solution, which is A plus B. A plus B, I start at A, or at the tail of A, and I end at the tip of B. And this is A plus B. So if you notice, the horizontal component is 1, 2, 3, 4, 5, 6, 7. And the vertical component is 2. One way that we can write that is 7, 2, like this. Or we could also write it like this. So a 0 vector means that the vector has a length of 0, so it has no magnitude. One way that could happen is if we take a vector, and if this is our A vector, if we add the same magnitude but opposite direction, so we're starting and ending our vectors in the exact same spot. So that would be 0. Or if we have a vector and we add a 0 to it, that's not moving at all. So for this question, I'm going to take R, which 1, 2, 3, 4 is 4 units horizontally, none vertically. Then I want to subtract S. So that means that it's the same size, magnitude, it's just an opposite direction. So it looks like it's -1 horizontally and -3 vertically. So I'm going to start with R, and I have 4 units, 1, 2, 3, 4. And then I'm going to subtract S, so 1 horizontally and 1, 2, 3 vertically. And I'm going to call that -S. So my resultant vector is R minus S. So therefore, it has the position of 1, 2, 3 horizontal units and 1, 2, 3 -3 vertical units. And that is R minus S. Go ahead and try the other one on your own. You can pause it, and then when you come back, you'll see the solution. So pause now. Here is the solution for you to check your answer. So for the next example, they're asking us to add vectors, and they're not telling us what the vector looks like, but that's okay. So the first thing I want to remind you that if I have the vector AC, the next vector that I add has to start at C for them to be added together. But as you can see, my second vector actually starts at B. So that means that they're not going to be attached. So what I need to do is I need to change the direction of this vector. So I'm going to change this to be a positive. And then I can change the C first. So now I have AC plus, because the negative, and if I'm going to change the direction, I have another negative, which together become a positive. So now what I have is AC and CB. Now if I'm going to add DB to it, again, I can't add DB because my tip that I'm resultant in right now is a B. So I also need to change this to be BD. So it's going to be a positive. So what's happening is if I'm taking AC and I'm adding CB, AC and CB, what do I have? Well, I actually have AB is what it simplifies to be. And then if I'm going to take AB and I'm going to add BD, let's just say that BD goes here. Well, then what do I really have as my answer? Well, I have AD. So what I want to show you is that as long as the tip of the first vector is the same as the tail as the end vector, then the new vector are the outside letters. Again, I'm just going to do a graphical example here. 2r. Well, 2r just means that I have the exact same vector twice. So I have 1, 2, 3, 1, 2. So 3 horizontal and 2 vertical. So I'm going to start here. 1, 2, 3, 1, 2. 1, 2, 3, 1, 2. So there's my 2r. And then I'm going to add s, and that looks like it's 2, negative 2. So my resultant vector is 2r minus s. You can go ahead and try b. And if you want to check your b, there it is. Now, I've been talking about the horizontal and the vertical components of a vector, but here it is formally. Your horizontal component is the top of the vector. The vertical component is the bottom of the vector. Now, let's put some algebra in this. What if instead of counting them and doing them graphically, we actually just add the horizontal components together and we add the vertical components together to get our resultant vector. So if I want to add a and b, a plus b, 1 plus 4, and negative 3 plus 7. So I get 5 and 4. Go ahead and do that graphically to check that your resultant vector has a horizontal component of a 5 and a vertical component of 4. I'm not going to do that. Now, what if our vector actually exists in three-dimensional space? So here is our three-dimensional graph, and as you can see, that means that we have an x component. So our x-axis is actually kind of coming towards us. Then our y it looks horizontal to the right, and then our z is up. So if this is the point here, and try and visualize it from if you have a cube, it's that back bottom left, and it's going through a three-dimensional space to the front top right. So our x component, our y component, and our z component, those three together create the position vector. Now, if we have a and b, so where it begins and where it ends, then to actually find the position, to find the position vector, we're taking where it's ending. So I guess I call that the tip. And we're subtracting the tail where it's beginning. So the vector AB, so AB, we're really doing x2 minus x1. So for this example, if I'm trying to find the vector of OA, well, this is just the origin. So that means that it's 0, 0, 0. And if that is the tail, and here's the tip, I'm going to do tip minus tail. So 0 minus 3 for my x, 0 minus negative 1 for my y, and 0 minus 2 for my z. So that becomes negative 3, positive 1, and negative 2 as the vector 0, it's not 0, OA. For AB, that is the tail, this is the tip. So AB is tip minus tail. So B, we would have 1 minus 3 0 minus -1, and -2 minus 2. Which ends up, I'm just going to go this way because I have room, -2, 1, and -4. Well, now that I've actually found the vector, and remember that's our x, y, and z direction, well, what about the length of it? That is our magnitude. So we actually use our distance formula. Because we've already subtracted, right? We already subtract our x2 minus x1, y2 minus y1, and z2 minus z1. So really we're just finding the distance. And that is where we will end, other than the fact that notice that this is the absolute value because a distance has to be a positive number.